Hello everyone. In this video we're going to talk about the stacks, yet another kind of data structures. And here you can see a drawing that represents how we are showing the stack. So stacks are LIFO data structures, or another, we're just going to write it LIFO, or last in and first out. So we're going to see that. What does it mean? That last in and first out. So as you see, one side of the stack is closed, so it's a dead end, and the other side is open. So there are a lot of examples of the stacks in real world. For example, we can see a pile of plates when you go to, for example, a restaurant, and you like to maybe a buffet or something, and you see that there's a pile of plates. You can just it yourself, and that's an example of the stack. Usually we're picking a plate from the very top of the that pile of plates. So, and if you want to add in any other plates, we're always adding to the very top. So all interactions, all the operations will be done on anything that is on top of the stack. So we're going to see that what are the operations exist in stacks. We have a push method, we have the pop method, we have is empty method maybe, or maybe clear method. We can define many other methods. For example, what the size of a stack, that which means that how many items do we have in on top of this stack, or if we are using for example arrays to implement the stacks, what is the capacity or the maximum number of items that can be stored on top of this stack. So with this introduction, let's see that how we can actually implement the stack. So for sure there are several ways to do that. Maybe we can use a linked list as I have discussed about in my previous videos, or maybe we can use an array in order to do that, or maybe even some other data structures. But I'm going to show the linked list for now, and we can also talk about using an array to implement a stack. So if you remember, or if you have watched my previous videos, I have explained how the double linked list with the head and tail works. And we have some methods in linked list, such as the push back method and push front method, also pop back and pop front. So we're going to see that how we can implement the stack using linked list by using the operations that exist for a linked list. So I'm going to draw a linked list here as well. So as we know, the very first node has a nickname called head, and then the very last node also has a nickname called tail. So here is our linked list, and here is our stack. So I'm going to just write the name here, and here is our linked list. And now how we can convert a linked list to a stack, or in other words, how we can use a linked list to implement a stack by using the operation that exists for the linked list. So as I said, the stack is a LIFO or LIFO data structure, I mean last in, first out. So anything that you put on the top of the stack will be popped first, or anything that you put at the very beginning will be the last item that will be popped from the top of the stack. So if we just, for example, if we have a linked list and we call, for example, the push back method or to push an item on top of the stack, then also we can use the pop back method in order to pop something from the linked list. So I'm going to write an example of how the stack works, like the push and pop methods. So for the push method, let's say we're gonna push, and here we're assuming that we're all working with the numeric values, but again, it can be anything. It can be any kind of the data that we're going to insert. Let's say we're going to push number 5 on top of this stack. So number 5, as you see, because the stack is empty, it's gonna go here at the very beginning or at the very bottom of like the stack. Let's say we're gonna push another number, let's say 10. So 10 goes here at the next available place, which is on the top of the stack. And let's say we're pushing another item, let's say 12. So 12 will go here. And now let's say that we're gonna pop, and pop doesn't have usually parameters because we're gonna say that it's return. So pop, and we're gonna say what's gonna be returned. As you see on top of the stack, the number here is 12. So when you call the pop, number 12 will be extracted. So what's going to happen? This number 12 will go away. So in other words, this number 12 will go away and doesn't exist. So here, and then we're gonna, the top of the stack will be 10. So if I call the pop method one more time, this time what is on top of the stack is this number 10 here. So number 10 will be popped. So now on the top of the stack I will have number 5. So what I can do, I can just remove these items here, and now what is on top of the stack will be this number 5 here. So if I call the pop method again, number 5 also will be popped. So we're going to see that how these push and pop methods can be implemented using a linked list. So I'm going to create a class, and as you may have noticed in a lot of my videos, I'm using a code very similar to Java, like a language. So I'm going to use like the same thing that I was using as before. So a class called stack, and here I'm assuming that we already have implemented the class linked list. You can again watch my videos about the double linked list. I have implemented the double linked list with the head and tail with the methods required to have a complete linked list. So for the stack, what we need like a storage. What we need a place to store the data, and then we need also the methods, such as the push method, such as the pop method, maybe a top method, which is return without removing what is on top of the stack, and some other methods, such as for example is empty or clear maybe methods, or like a method called is full, so just to know that if we have reached the capacity of a stack or not. So I'm going to create a storage first. So it's going to be a linked list. Also is generic, so that T here, as you see, means that these are generic. So the type T can be assigned later. Again, it can be numeric, it can be or any other kind of like the data type. So linked list, and let's call this one storage, which means that the data will be stored in a linked list. So one maybe good thing to keep is what is the size of the stack, or in other words, how many items do we have on top of the stack. So going to the implementing some methods such as the push method, I'm going to see that how we can actually convert the linked list to the stack. But let's use a drawing. That's always I always suggest to use drawing when you are trying to understand some concept. Here, if we somehow rotate 90 degrees this linked list, we can see that the header will be at the very bottom, and tail is always on top of the stack. So if you rotate these linked lists 90 degrees, the tail is always the last item or the top item, and the header is the very bottom item. So as we notice or we learn about the stacks, we always work with the very last item or very top item. So if you think it from the linked list perspective, it is actually working with the tail node. So if I'm going to add an item to the top of the stack, it is like I'm adding a new node after the tail, which is in other words the pushback method. Also, I am removing always from the top of the stack, which means I need to remove from the linked list perspective, I am removing a node from the very end of the linked list, which is the popback methods. And I'm assuming that we have implemented these methods for linked list. Again, you can watch my previous videos about double linked list and the pushback and the popback methods. So here with this explanation, I'm gonna write or implement the push and pop method. So push method. Again, we have like there may be some data that here we have. So, and then here again, we're assuming that our data structure used as the core of like storing data is a linked list. So we're not too much worried about maybe the capacity of the stack. If we are, we can just add a condition to the push method that if we have reached the capacity, do not add, maybe raise an error. Otherwise, we can just simply call the pushback method. So storage dot push back. We are passing the data, and that's it. That's the push method. So, and again, we don't need to be worried about the implementation of the pushback. We're assuming that it's already implemented. So when we say pushback, push method for a stack, it means call a pushback for a linked list. And if we want to implement the pop method, so the data that needs to be like the return. So we're assuming it is type T. And so again, usually it doesn't have any parameter. And here we need to simply return their storage dot popback method. And that's it. So very simple way to implement a stack using a linked list, assuming that we have a double linked list with methods called pushback and popback methods. Again, if we rotate the linked list like to the left in 90 degrees, we can see that it actually can resemble a shape or the shape of like the stack, and we can use the pushback and popback methods to that one. So for implementing some other methods, such as for example the top method, which will not remove the very last item. Instead, maybe we can just say return storage dot maybe tail, something like that. We can just have it. Again, we are not worried about the details of the implementation or like encapsulation here. We mainly focus on the way that we can access. Maybe we have a method called get tail that will return, but again, we're not too much worried about like the defining the header or tail or other stuff like is a private or protected. Most of our focus is on just the concept itself. So if you want to return the size of also the like the stack, for sure we can return the size of the linked list if we have already implemented a method for returning how many items do we have in the linked list. And again, it's very easy. Anytime that you call the push method, either push back or push front, you increase the size of the linked list by 1. Even if you don't have the implementation of the increasing the size in linked list, anytime that you call the push, you can increase the size by 1, or anytime you have a pop from the stack, you can decrease the size by 1. So it's very easy to see that how it works. That's like most of like the things that we can discuss. There are some other methods. For example, is empty, really easy to implement. You can just say that if the size, for example, is 0 or not, very easy to do that. Or maybe clear, which is removing all the items from the stack and is nothing rather than just calling the pop methods maybe many times, or which is the exactly the number of sizes, or what is based on the size of the stack. So if the size is 10, call the pop method 10 times, and it's gonna clear the stack, which will remove every item from the top of the stack. So if we now think about what is the time complexity of this operation. So what is the time complexity of the push method, and what is the time complexity of the pop method? Because here we use a double linked list to implement the push method and the pop method, or in general stack. So we need to see or find out what is the time complexity of the pushback method and the pop back method in the linked list. As we learn, and you can again watch my previous videos, pushback method in a double linked list, when we have access to the tail, is from the big 1. So we can say that push method in the stack using the linked list will be from the big 1. So again, big 1 means that it is a constant number of operation, which is not depending on the size of the input, or in this case maybe the linked list size. And also the pop method, because again we have access to the tail, and also we have access to the previous nodes of the tail. The pop back method also is from the big 1. So we can conclude that the push method and pop method in a stack can be implemented in big 1 time complexity. So here is this is the explanation of or implementation of a stack using a double linked list with a head and tail, and both push and pop operations in the time complexity of 1. So it's very easy to see that the top method also is from the big 1. Very easy to see that because it's going to return only the tail, and the size method also is from the big 1 because we need to just return the tail. In other hand, the clear method, which is going to remove all items from the stack. So the clear method will be from the big n, because there are n items on top of the stack, so we need to remove all of them. In other words, n here is the number of items or items on top of a stack. So, and we need to remove all of them. We need a loop structure. Maybe we can use a for loop or a while loop while the stack is not empty to repeat that, and it's going to be based on the size of the stack. So out of all of these operations, the only one that has the big O of n is the clear method. So in my other videos, I'm going to talk about implementing a stack using an array.